Okay, last two podcasts in this unit, I promise, are going to be real sweet. They are going to be practical application questions, which are really, really cool. Look at this one. Number 12 says, an open-topped box is being made from a piece of cardboard measuring 12 by 30. So the original cardboard here is 12 inches this way by 30 inches that way. But it says the size of the box are formed when 4 congruent squares, each one of these is cut out. They cut it out to form the corners so that they can flip the box up and actually make a box. And then the base of the box has an area of 208. So how do you figure this out? Well, area I know. Area is length times width, but the length is not 30. If you think about it, the length lost an x value here and lost another x value here. So if you think about it, the length is 30 minus 2x values, right? And then this here, if you think about it, that's an x value and then that's an x value. That means the width, which was 12, lost 2x values as well. The area then being 208 squared. Now, there's several different ways you can do this. Most people will say, okay, multiply this out, PSA or complete the square, or turn around and use, let's say, something like the quadratic equation to solve this and so on. I'm saying, nah, this is an equation right here. Let that be y1. This, let it be y2. This, y1, is going to give you some sort of quadratic. Bada-boom. y2 is going to give you 208. So there's your 2x values, either here or there. Pick one and see which one works. Let me prove this to you. Okay, so here we go. The first thing I'm going to do is I'm going to put these two equations in. 30 minus 2x, 12 minus 2x into my calculator. So here we go. Bracket 30 minus 2x. Bracket 12 minus 2x. Bracket. Okay, so there it is. And then I'm going to put my next part, which is what the volume, or I should say what the area equals to. The area equals to 208. So I'm going to put 208 here. But remember, your graph was set up as Zoom standard. So look what you're going to get when I sit and I graph this. It's going to sit and it's going to give me that. Wow, what is that? Well, that means you haven't seen any of the parabola. And if you look, you'll notice that the parabola here looks like it's coming this way. So it's probably going to go way down here and come out here. So I think we should expand this over. Let's drop the bottom of this a little bit maybe. But notice also 208. This is only 10. So I have to really increase that. Well, I'm not too worried about what the vertex is here. I want the intercepts. I want this intercept to show, but I specifically want this line to come over here so I can find my two intersects and find my x values that equal up to 208. Okay, with all that being said, let's go out and let's play with the window settings. All right, so here we go. Window. Let's find the x values. Well, the x max, let's boost that out there. Let's make this about 50 and let's see what happens. So graph it. Let's see if we get two parts of it. Ah, we do. So 50 is a little bit too much. Let's drop this down. Let's make this, oh, I don't know, let's make it 25. Let's see if that shows up real pretty. And in fact, it does. Okay, so there's my two intercepts, really pretty. Now, let's take a look and go back to the window. And now remember our Y max, which was at 204. So I think I would make this Y max, let's say 210, just so that we can see the top of the graph. Graph it again and let's see what we got. Boom, there's a nice looking parabola, and there's my intersects right up here. So my intersects are this intersect here and this intersect here. Let's find those x values. Okay, so how do we find them? Well, simple. Second, calculate. Let's find the intersect, 5 of those two things. So here, let's move this back over here. Let's find this guy. Oh, here it comes, right up there. Enter, enter, enter. My first value is x equals to 2. But notice it says 208 here. Was that my value? My value is 208. Look at that. My value was 208. But what am I after? I'm after my x being equaling to 2. So I have a possibility of x equals to 2. Great. Let's find our other possibility. Second, calculate. Let's find my intersect again, which is 5, and let's mouse over to the other one. Here we go. Do 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 do, and up we go. Here it comes any second now. Can I go past him? No, there he is. There he comes. There it is. And enter, enter, enter. I have an x equaling to 19. So which one of those do you use? Both of them are positive. Both of them look legit. You can say x equals to 2 or x equals to 19. Let's figure it out. Well, probably the easiest way to do this is substitute it back into here and see what happens. If I used x equals to 19, look, 30 minus 2 times 19. Well, wait, 2 times 19 is 38. 30 minus 38 gives me a negative 8 for a length. That's impossible. So the x has to be equal to 2. And if we substitute that in, let's get rid of this. Let's substitute that in. We go 30 minus 2 times 2. 2 times 2 is 4. 30 minus 4. Our length is now a wonderful 26 inches. Beautiful. Okay? Same goes with our width over here. Let's clean this up and let's do our width. Our width here is 12 minus 2 times 2. 2 times 2 is 4. 12 minus 4, that's 8. We have a width here that's going to be 8 inches. So if you're trying to figure out the area at the bottom of the box, that's easy. 26 times 8, that better give us 208, or we're in a heck of a mess. So 26, clear, clear, clear. 26 times 8, and we get 208. So we know we've done this right. What a beautiful question in terms of designing a box. Awesome, awesome, awesome.